This is the second half of the 1.3 notes. So this is like 1.3 continued. You could think of it as 1.3b. We're going to talk about dividing radicals in this lesson. So to divide radicals, here's the steps. Step 1, divide the coefficients, then use the quotient rule, which says that if you have radicals with the same index, you can divide their insides. So again, this is an inside with inside kind of a thing. So when dealing with radicals, it's always outsides with outsides, insides with insides. And then step 2 is to simplify the resulting radical. So looking at number 1, outsides with outsides, we've got a 12 and a 2. 12 divided by 2 is 6. And then insides with insides, so we can do 160 divided by 5, which is 32. So that simplifies to 6 square root 32. And then we'll need to simplify that if we can. 32 is 2 and 16. 16 is 4 and 4. I'm going to stop there since we're looking for groups of 2 things. 2 4s with the 2 left over. So we'll pull out the 6 times the 4, which is going to be 24. And then the 2 in left inside of our radical. So that whole expression simplifies to 24 square root 2. Awesome. Number 2. So we'll do insides with insides, outsides with outsides. So 36 divided by 9 is 4. And then those 2 radicals have the same index, so we can divide them. So we'll do 1250 divided by 2, which leaves us with the 4th root of 625. And then we'll just need to simplify that. That would be 25 times 25, which are each 5 times 5. So it looks like the 4th root of 625 is actually just 5. So this becomes 4 times 5, which is 20. Next, we'll do it with some variables, but the principles remain the same. Insides with insides, outsides with outsides. So we've got x cubed divided by x squared. If you remember from our exponent lesson, you can subtract those. So we get x to the power of 1, and then y to the 9th over y to the 5th. You subtract those, and you get y to the 4th. Then we go ahead and simplify that. The x can't come out, but there's 4 y's, and we need groups of 2, which we have 2 groups of 2 with none left over. So that's going to become y squared times the square root of x. Alright, number 4. I want you to do that one on your own. So pause the video and do that one. Okay, so that will become 7 cube root negative 16 divided by 2 is negative 8. M to the 6th divided by m is m to the 5th. Simplifying that, we get negative 7 times 2m, and then the cube root of m squared. So this would be negative 14m cube root of m. Number 5. Well, this one's nice because they put the fraction inside for us, so we can just divide those numbers. So 48 divided by 16, that is 3. So that's going to be the square root of 3. Number 6 here, 40 divided by 27, that does not simplify nice. Those have no common factors, actually. So instead, what we're going to do is we're going to separate them like this. into two separate radicals and then simplify both of those. So 40 is 4 and 10, 4 is 2 and 2, 10 is 2 and 5. Looking for groups of 3 things. So that numerator is going to become, we can pull a 2 out, and then it'll be the cube root of 5. And then on the bottom, I'm pretty sure 27 is 3 times 3 times 3, so the cube root of 27 just simplifies to 3. So sometimes what you'll have to do is to break it down into two separate radicals and then simplify. Number 7 here. 7 and 64 have no common factors, and then x and y can't be combined. So we'll need to do that same thing here. Break this into two separate radicals. So it'll be the cube root of 7x to the 5th over the cube root of 64y to the 6th. Breaking those down, 7 is prime, so it can't simplify, but there's 5 x's and we need 3. So we can pull out 1 x with 2 left over. And then on the bottom, 64 is 4 times 16, and 16 is 4 times 4. So that's a group of 3 things. And then we have, so that would be, we can pull out a 4. And then we have 6 y's, which is 2 groups of 3. So we can pull out all of the y's. And that simplifies. So that would be our final answer there. Alright, go ahead and pause the video and try this one on your own. Again, you would have to break this one into the pieces. Your final answer is going to be 2/4 root of 2w over 3. Alright, the next big idea is something called rationalizing the denominator. What I mean by rationalizing the denominator is that the bottom cannot have any radicals. No, I'm even going to write that in red so it feels important. The bottom cannot have radicals. For some reason, this is something that the math community says is bad. And so we have to learn how to get rid of radicals in the denominator. So what we do when there's a monomial denominator, meaning it's not added or subtracted from anything, is we're going to multiply the numerator and denominator by the radical. So looking at number 9 here, what's the problem? Well, the problem is that we have a square root of 5. So to rationalize this, we're going to multiply the top and the bottom by the problem, which is the square root of 5. So on the top, we do insides with insides and outsides with outsides. So that'll just be 3 square root of 5. On the bottom, we'll get 2, and then those insides together is 25. But the square root of 25 is 5, so this will become 3 square root 5 over 2 times 5, which is 10. So that number rationalized would be 3 square root 5 over 10. Alright, number 10 here. I would first write this as two separate radicals just so that for my brain I can see what the issue is. So we got the square root of 8 over the square root of 15. And then what's the problem? Well, it's the square root of 15 on the bottom, so you have to multiply the top and the bottom by the problem. 8 times, so on the top we can do insides with insides, so that becomes the square root of 120. On the bottom, just notice that this is going to become 15 times 15, which is a group of 2 things. So this is just going to be 120 over 15. Any radical times itself is just the radicand. So then we'll break that down. 120 is 12 and 10. 12 is 2 and 6. 6 is 3 and 2. 10 is 2 and 5. This is a square root, so we need groups of 2. That did not work very well. Let me do that over here. So we've got 12 and 10, maybe 3 and 4, 2 and 5, 2 and 2. Groups of 2 things. We only have one group. So that's going to become 2, and then we'd have left over 3 times 2 is 6 times 5 is 30 over 10. Sorry, 15. And then it's tempting to think that we can do 30 divided by 15, but remember, insides with insides, outsides with outsides. So we could do 2 with 15, but those don't have any common factors. So that would be our final answer. Alright, let's keep going. So we can't simplify that any further. Well, we could. Square root of 12 simplifies, but let's rationalize the denominator first. So square root of 7 is the problem, so we'll multiply the top and the bottom by the problem. Remember, do insides with insides, outsides with outsides. So this will be 3. 7 times 12 is 84. So 3 square root of 84 over 4. And then remember, any radical times itself is just the radicand. So that square root of 7 times square root of 7 is 7. And then let's break this down. 84 is 7 and 12. 12 is 3 and 4. 4 is 2 and 2. So looking for groups of 2 things, we've got one of them. So this will become 3 times 2, which is 6. And then left inside, we have the 7 and the 3. The 7 and the 3. So that's going to be square root of 21. And then on the bottom, we have 4 times 7, which is 28. And then here, remember, we can do outsides with outsides. Do 6 and 28 have any common factors? Well, yeah, they do. They're both divisible by 2. So this is going to become 3 square root 21 over 14. Alright, next one. So this one is one where it's handy to do insides with insides first. 32 divided by 3, that can't be simplified. But a to the 5th divided by a can. That's going to be 5 minus 1, which is 4. And that's going to remain on top. So we'll have 32 a to the 4th over the square root of 3. Since we put those a's together. And then from here, we'll have to rationalize the denominator. Which means we'll have to multiply the top and the bottom by the square root of 3. 32 times 3 is, you know what, I'll write it down here, is 96 a to the 4th. And then the square root of 3 times the square root of 3 is just the radicand, which is 3. And then let's break down 96. 96, isn't that divisible by 12? It is. It's 12 and 8, which is 3 and 4, which is 2 and 2. 8, if you're okay with it, is 2 times 2 times 2. Looking for groups of 2 things. We'll have a 2 and a 3 left over. So this is going to become 2 times 2, which is 4. And then we can pull out, there's 4 a's, so that's 2 groups of 2. So we'll have a squared, and then left inside is 3 times 2, which is 6, all over 3. Which does not simplify anymore, since 4 and 3 don't have any common factors. Alright, 13. So again, we gotta rationalize our denominator. The problem is the square root of 2, so I'll multiply that on the top and the bottom, but be careful here. You have to distribute it to both of the pieces on the top. So you got to distribute it to both things. So square root of 8 times the square root of 2 is the square root of 16. Subtract the square root of 2 times the square root of 2, which is 4. And then on the bottom, we have the square root of 2 times the square root of 2, which is going to be the radicand. Well, the square root of 16, we know that, that's 4. The square root of 4 is 2. So if we get 4 minus 2 over 2, 4 minus 2 is 2. 2 over 2 is 1. So that one actually simplifies all the way down. Alright, and this is where you practice. So go ahead and pause the video and do that one. Alright, gotta rationalize that denominator by multiplying by the square root of 12. On the top, be careful though, you gotta distribute it. So we'll do 3 square root 2 times the square root of 12, which is 3 square root of 24. And then we'll do square root of 6 times the square root of 12, which is the square root of 72. And then on the bottom, the square root of 12 times the square root of 12 is 12. Let's go ahead and break those down. 24 is 4 and 6, which is 2 and 2. So we'll have 2 with 6 left over. So that will become 3 times 2, which is 6. 6 left over. 72 is 8 and 9, which is 3 and 3. 4 and 2, which is 2 and 2. So that's gonna be 3 times 2, which is 6, with 2 left over 12. And then notice right here that all 3 of these coefficients have a common factor, so this actually can be taken one step further. If you didn't notice that, that's okay. Their common factor is a 6, so you can divide all of those by 6. So you'll get 1 square root 6 plus 1 square root 2 over 2. That would be the most simplified form of that answer. Alright. And our final idea for this lesson is binomial denominators. So this is when you have some addition or subtraction happening in your denominator. The thing that we talked about earlier where your denominator can't have a radical still applies. But in order to get rid of it, you can't just multiply by the radical. You have to multiply something called the conjugate. And the conjugate just means that it's the same thing here, but you're just going to change the sign between them. So the conjugate of 4 plus 2 square root 2 is 4 minus the square root of 2. So we're going to do that on the top and the bottom. And be careful on the bottom. That is going to be a thing that you have to FOIL. So on the top, you're going to have to distribute. So you'll do 4 times 4, which is 16, and then 4 times negative square root of 2, which is negative 4 square root of 2. And then on the bottom, you got to FOIL. So you're first going to do 4 times 4, which is 16, and then 4 times negative square root of 2, which is negative 4 square root of 2. Square root of 2 times 4 is positive 4 square root of 2, and then square root of 2 times the square root of 2. Well, when you have a square root times itself, it's just the radicand, so that'll be negative 2. Now this is the reason that you multiply by the conjugate. Notice these have the same radical, and the coefficients are opposite signs. So negative 4 plus 4, those just go to 0, and you're left with 16 minus 2, and that will always happen when you multiply by the conjugate. So this will be 16 minus 4 square root 2, and then 16 minus 2 is 14. Notice that 4 and 14 all have a common factor of 2, so we can divide everything by 2. We'll get 8 minus 2 square root 2 over 7. Number 16 here. To get rid of the radical in the denominator, we gotta multiply by the conjugate, which is 6 plus the square root of 5. Be careful to distribute appropriately. So on the top, 2 times 6 is 12. 2 times the square root of 5 is 2 square root of 5. On the bottom, 6 times 6 is 36. 6 times the square root of 5 is 6 square root of 5. Negative square root of 5 times 6 is negative 6 square root of 5. And then negative square root of 5 times the square root of 5 is negative 5. So just as it always should be, these are exact opposites. So they take care of each other. So then we're going to have on the top 12 plus 2 square root of 5. And then on the bottom, we have 36 minus 5, which is 31. 31 is prime. So that would be our final answer there. Alright, number 17, we're almost there. We're going to multiply by the conjugate, so 1 plus 4 square root 2 on both the top and the bottom. Be careful to distribute appropriately. So on the top we'll have 1 times the square root of 3, which is the square root of 3. Square root of 3 times 4 square root of 2, remember outsides with outsides. So that's 4, and insides with insides would be the square root of 6. On the bottom, 1 times 1 is 1. 1 times the 4 square root of 2 is 4 square root of 2. Negative 4 square root of 2 times 1 is negative 4 square root of 2. And then those last ones, let's do insides with insides, outsides with outsides. So negative 4 times 4 is negative 16. Square root of 2 times the square root of 2 is 2. So this becomes 1. Those 2 are exact opposites, so they go away, and then negative 16 times 2 is negative 32. Sorry, I forgot to write the numerator. And all of that is over negative 31. You can keep that negative on the bottom, or you can move it to the top and switch all the signs on the top. Either way is valid. Alright. Let us do one more, and then you guys have seen everything. And we'll call it a day. So let's go ahead and multiply by the conjugate here, which is the square root of 5 minus the square root of 3. Careful with those parentheses in your multiplication. So on the top we gotta FOIL. So 5 times the square root of 5 is 5 square root of 5. 5 times negative square root of 3 is negative 5 square root of 3. Negative square root of 5 times the square root of 5 is negative 5. Negative square root of 5 times the negative square root of 3 is positive square root of 15. On the bottom, we've got square root of 5 times the square root of 5, which is 5. Square root of 5 times the negative square root of 3 is negative square root of 15. Square root of 3 times the square root of 5 is the square root of 15, and then positive square root of 3 times negative square root of 3 is negative 3. As per usual, these are opposite signs. On the top, unfortunately, we can't combine anything, so that's gonna stay just as nasty as it is. And on the bottom, we have 5 minus 3, which is 2. I'm just looking real quick to make sure we've seen everything that you need to know how to do. Looks like it. So we'll go ahead and stop there. Don't worry about doing those 2 examples.